So let's start with a single function where we have q as a function of v. The first theorem says if we have q equals to av plus b, where a and b are constant, then the limit of q where v approach to n is an plus b. For example, we have q equals to 5v plus 7. Then the limit of q when v approaching to 2 is just 5 times 2 plus 7 equals to 17. Now the second theorem, if we have q equals to b, then the limit of q when v approach to n is just b. Or in other words, the limit of a constant function is the constant in that function. So the next one is if we have q equals to v, then the limit of q where v approaches to n is just equal to n. And the next one, if we have q equals to v to the power of k, the limit of q where v approaches to n is just n to the power of k. And now if we involve with two functions where the two function has independent variable, and let's just set the condition. We have two functions, q1 and q2, where both of them, q2 is a function of v and q2 is also a function of v, where the limit of q1 if v approaches to n is equal to L1, and the limit of q2 where v approaches to n is equal to L2, where L1 and L2 are finite number. It should be number there. Thus, the first theorem is the sum difference limit theorem. If we have the limit for q1 plus q2 where v approaches to n is just L1 plus L2. The product limit theorem says if we have q1 times q2, the limit of q1 times q2 where v approaches to n is just L times L2. And for a function where it's a quotient function, the limit theorem says that the limit of q1 divided by q2, the function of q1 and q2, where v approaches to n is just L1 divided by L2. So let's work on an example here. If we have this function q equals to v minus 2 times v minus 3, based on the product limit theorem, we can work it like this. The first one we do for the first function, limit v approaching to 4, where q equals to v minus 2. Then we have limit v approaching to 4, q1 is just 4 minus 2 equals to 2. And for the second one, limit q2 equals where v approaching to 4, I'm sorry, this is not clear, v minus 3 is just limit v approaching to 4 for q2 is 4 minus 3 equals to 1. So based on the product limit theorem, we have limit q v approaching to 4 is just 2 times 1 equals to 2. And for the very last theorem is the limit in a polynomial function. We know that the polynomial function has a form as follows. So if we want to find the limit of the polynomial function like the others, we try to find the limit. We can divide each functions, yeah, and work on the limit based on each function. This is a constant, and we know based on the constant limit theorem, the limit for a constant function is just the function itself. And the limit a1 times v approaching to n is just a n, and so on. So the limit, if it is a polynomial function based on the sum limit theorem, we have that the limit of q, where v approaching to n, is just the sum of each of the function that we have worked. So that's it about the limit theorem.